Cameras. All right, cameras up and rolling. So what we're going to do today is I just want to spend a little bit of time talking about the Campos article that hopefully you were able to at least review. If nothing else, you got a chance to review the tables and the figures, which I think are probably the most valuable part of this paper. So I want to talk through that. I'm just sort of excuse me if I look down here. I'm just trying to get a list of everybody who has logged in today, just so that I can keep track for my records. So I'll go through that article, and then what I want to do is open up to any questions you may have for the exam on Thursday, or any questions related to your project, which is due 1 week from today, 5 o'clock, in the electronic Dropbox. Okay, so that's sort of the plan for today. Hopefully we won't be here too long, and then later this afternoon I will work to get the link put up for YouTube so that you can again review the lecture before the exam. But all of this stuff you should have seen, or at least been a part of, because the exam is only on the resistance stuff at this point. So let me fire up my presentation here.
The project's due 5 Eastern, correct?
Correct, 5 p.m. Eastern time, please. Let's see. This one. Yeah, we'll do this one. Okay. So everybody have the presentation screen? Everybody can see the presentation screen up there? Okay, awesome. So I want to talk today about this idea of the strength endurance continuum. And really what that ultimately indicates is that whenever we're doing resistance training, there's always a relationship between how we train and the responses that we're going to see, right? This is also known as the SED principle, specific adaptation to impose demands. So whatever we impose on our athletes, or whatever stimulus we give them, they're going to get better at doing that. And it's been shown a number of times. We've seen it in a couple of studies already. But this study by Campos really speaks specifically to the idea of prescribing weight training or resistance training to the athletes. So we're going to talk about how this works out in somebody who is prescribed low repetitions at a high weight or high repetitions at a low weight. And just to define those, when we talk about low repetitions, we're talking about 3 to 5. Intermediate, we're talking 9 to 11 reps, and then high reps, typically anything over 15, but in this case, we're going to talk 20 to 28 repetitions of an exercise. And so we know that the weight and the number of reps you can do is inversely proportional, that as the weight goes up, you're able to move it less times overall. And so that's really where we're going to spend time talking about the strength endurance continuum. It's also known as the repetition max continuum or repetition training continuum. All of those things are pretty much the same. So basically a continuum looks like this. You can think of a continuum as a straight line, arrows headed in both directions, and the fact that you can put any value on the continuum from high to low. Another example, I'll open up my markers here. Another example of a high-low continuum might be something like temperatures, okay, like a thermometer, where we have temperatures from very low to very high temperatures that we might experience, right? And so each point on this continuum can move in either direction. Okay, the day gets warmer, moves along this way. The day gets colder, moves along this way. Another weather example would be wind speed can get higher or lower. So really anything that falls along a straight line that we can number and document is this idea of a continuum. Speed in your car, your speedometer is basically a continuum from 0 miles per hour up to as fast as your car can legally go. Notice I said legally, people. So what we can also plot along the strength endurance continuum is just those two things. One end of the continuum is going to be focused on strength benefits. The other end of the continuum is going to be focused primarily on muscular endurance benefits. And we also have 3 separate categories that we can put along this continuum anywhere, just like we denoted all the different temperatures that we can have. We can also have all the different weights. Now, what weight is going to be all the way at the very tip of this arrow, all the way in the strength side? What weight did we estimate for people?
1 rep max.
Yeah, so their 1 rep max, someone's 1 rep max is going to be all the way at the end of the continuum. And that's going to be the maximal amount of weight that they can move one time, right? And so by low repetition, that means we can do it once. That also means that if we want to move that 1 repetition again, we're going to need a very high rest period in order to recover from our previous efforts. Now, if you go back to your 1 rep max table that we had there, as we lift the weight more times, the weight continues to go down. And so the further we move in this direction towards the endurance end of the continuum, this might be a weight that we can lift 30 times, right? And so it's going to be a lot lighter. And the rest that we need in between efforts is going to be minimal. So let's take, for example, something like a bench press. A bench press on the strength continuum, we can identify what our 1 rep max is. And that's going to be all the way down here. As we decrease the weight, maybe we end up only moving the bar on this end. Okay, and so we've decreased the weight all the way to the bar, or we can even go further and we can say, let's take that same movement and make it a push-up. Now we can do a whole lot of push-ups, or we can move that bar a whole lot of times because it's going to be lower weight. We're going to do high repetitions, and we don't need as much rest in between all of the individual efforts.
I have a point.
So all
is there
three of
supposed
these.
to be like?
What's
Is there
that?
supposed to be like examples of you like showing like the different reps and stuff like that on the screen?
It may not be transferring over.
Okay, yeah, because
So
like
I apologize for that. Let me see. Let's see if we can get something up here for you. Give me 1 second. We'll try this again. Kofi, are you alive? Okay, there we go. I thought you passed out on me. Let's see. Are you seeing stuff on the screen now?
I am.
All right. So basically what I was saying is, your 1RM is all the way down at our left-hand side, and then our endurance, where you're going to be doing push-ups or just moving the bar, you can move it a lot of times because it is a lighter weight. Okay, so we can take any of these three categories and place them somewhere along this straight line, the continuum. Okay, so we'll get rid of that. So this is the article I asked you to look at. It's an older article now from 2002 on the European Journal of Applied Physiology. But what it really looks at is 3 different resistance training routines. And it talks about the repetition maximum continuum that is so important when you are prescribing exercises for another individual. So this article looked at 3 different groups. The first group is on this strength continuum over here. They're going to be performing a very high weight exercise for low repetitions. And then they're going to get a lot of rest. So overall, this study looked at 32 untrained men over an 8-week resistance training program, and it divided them into 4 groups. And that first group is indicated here by this, by the green arrow or the green lightning bolt. This is our low repetition group. They were working on that 3 to 5 rep max, 4 sets, and they got 3 minutes rest in between each. The next group was right in the middle. This is what we'll call our intermediate repetition group. They worked at our 9 to 11 rep max. They did 3 sets, so the number of sets went down, and they got 2 minutes rest in between. So you can see that the rest has gone from high rest 3 minutes, it's gone down to 2-minute rest in between. Repetitions has gone from 3 to 5 up to 9 to 11. And even the number of overall sets has gone from 4 sets down to 3 sets. Okay. Our final testing group here is all the way on the other side. This is our high repetition group on the endurance, the muscular endurance side of the continuum. These people perform 20 to 28 repetitions over 2 sets with only a minute rest in between each. So you can see that rest, again, has moved from high to low, 3 minutes to 1 minute. Sets have moved from 4 sets all the way down to 2 sets. And then repetitions 3 to 5 on the strength end, all the way down to 20 to 28 repetitions on the endurance side. Now there was a 4th group in here. We'll put them down in the corner. That's our control group. Can anybody tell me what the control group did during this study? Or what do we normally like control groups to do during a study?
Nothing?
Absolutely, right? That's the easy way. We don't want our control group to be contaminated. We want them to go through the same 8 weeks, where we're going to measure them at the beginning of the 8 weeks and then at the end of the 8 weeks, but we don't want them doing any type of training. Now, this is all, again, these are all untrained individuals, okay? 8 individuals in each of the 4 groups. What else do we know about the first 4 to 6 weeks of resistance training in an untrained individual? Where are they going to see improvements?
Isn't it just neurologic?
Yeah, more than likely, all we're going to see are motor control improvements in those individuals. So we're going to see neural adaptations. This study is nice because it does extend to 8 weeks. So we do hope to see some actual physiologic changes. However, we can't guarantee that A 12-week study would have been much nicer. However, it's hard to get people to commit to going through a 12 or a 16-week study. That's a long time. Okay, so the study looked at 3 exercises. The first 4 weeks, they did them twice a week. The next 4 weeks, they performed these exercises 3 times a week. They did a leg press, they did a squat, and they did a knee extension or a leg extension exercise. And so they were focusing primarily on the quadriceps muscles. They were really trying to isolate a specific muscle adaptation. And the reason for this was those are easy muscles to evaluate. So before and after the 8 weeks, they trained these individuals on these exercises according to whatever group they were randomly assigned to. And we get this final figure that comes out of the study. So what I want to do is have a little bit of a discussion back and forth with you about what the results of this study have shown us. So if you look at this continuum, you can look at it either here on the video, or if you have the paper open, you can look at it at the hard copy in the paper. But what I want to do is I want to orient you to what's going on here. So we have 2 columns. We have one on the left-hand side and on the right-hand side. The left-hand side column is all the strength gains. So how much did each individual's 1 RM improve? So they tested the 1 RM in the leg press, the squat, and the leg extension machine. The other graph here looked at taking 60% of the individual's 1 RM and seeing how many repetitions they could do with it, or how many times can you lift 60% of your maximal weight. And again, they looked at leg press, squat, and leg extension. So we looked at the physical performance of all of these individuals after 8 weeks of training on 3 different exercises. The 4 groups are represented in 4 columns. We have our control group, we have our low repetition group. Remember, they performed 3 to 5. Intermediate repetition went a little lighter and performed 9 to 11. And then our high repetition group went significantly lighter and performed 20 to 28 repetitions of a given exercise. And so the other thing I want to orient you to is the open columns are going to be pre-test. The filled in columns are going to be post-test. So we can see the difference pre to post for each of the groups on each of the exercises in both 1 RM and muscular endurance, the number of repetitions they could perform. So by looking at this, now that I've gone on and I've bored everyone to death, what does this tell you? Or tell me something that you see on here that pertains to the results of this study.
I feel like it's just an example of what you said earlier, that whatever stimulus we give our athletes, that's what they'll get better at, because whoever had the high repetitions like increased their repetitions, while the low repetitions with the high weight could move more weight.
Okay, so let me get my marker up here. So Aaron, what you've said is that the individuals who worked out at a low repetition, right? So they did the 3 to 5 repetitions. You see them all significantly improve in their 1 RM or their ability to move the maximal amount of weight. Is that appropriate?
Yeah.
Okay. What else? What else do we see? And this is open to anybody. So
I feel like the intermediate group had the most gains in both the 1RM and the endurance, just because they were kind of in the middle of weight and reps.
Okay, so let's look at our intermediate groups here. And if we look at the intermediate group on both the endurance side and the strength side, we see that there is a significant improvement in their ability to lift 1RM. We also can see here that there is significance. Remember, we're looking at these little denotations above the post-test. Those denote that there's a significant change. So they showed improvements in muscular strength and muscular endurance. Good. What else do we see here? Somebody give me something else that we see.
The high rep group has the greatest muscular endurance after the training.
Right? So good job, Jake. So if we look at what our high rep group did, look at this huge change they had in the number of repetitions they were able to perform at 60% 1RM. Now it's important to note the high rep group also had a significant improvement in their 1RM. So they still did see some muscular strength improvements. However, not as much as the other groups, right? They still had a little bit of improvement. What can you tell me about this column over here with our low repetition group on their test of muscular endurance? What happened here? In the group that performed 3 to 5 repetitions with a lot of rest,
Their endurance.
Go ahead, Jake.
Their endurance didn't significantly change.
Right? We see one point where their endurance may have increased. There's no significant change here, right? We don't see the little marking. And then what actually happened on their muscular endurance for the leg press?
Went down.
Yeah. It actually, the number of reps that they were able to perform actually decreased. So we've got an increase on one test, we've got a decrease on another test, and we've got no change. So really, what we can say here is that almost nothing happened. One goes up, one goes down, one stays the same. Okay? So they didn't improve their muscular endurance. What can be said about our control group? These guys, that first column in both sides. What can we say about that?
There was no change in either strength or endurance.
Right. Is that good or bad?
I think it's good for them being a control group, I guess.
Yeah, that's what you want to see. You don't want to see your control group change at all. If your control group changes, that means that there was an outside variable that had an effect on the results of the test. So this right here is a good test because our control group didn't change. So we can't infer that it was just the time of the year, right? You can imagine we can expect muscular strength to maybe improve if we go from winter to spring over the course of a study when people become more active. And so it's not a case of timing that we saw improvements in our control group. We didn't see any improvements in our control group. Good. So we've got all of these performance results indicated. Just what Aaron started us off with, that The group that was training in the high endurance had the greatest improvement in green on their 60% rep max. And the group that was training at a heavy weight, moving it only a few times, had the greatest improvement in their 1RM strength on the left-hand side in the red of the graph. So let's get rid of that. And let's go to another outcome table. This is table 5 out of the paper. Again, give me a second and I'm going to orient you to what this is talking about. So table 5, table 5 involves looking at the cross-sectional area of 3 major muscle fiber types. So what it looks at is it actually is a value of a muscle biopsy. So they go into the muscle with a huge needle, and I mean a huge, very big, thick needle gets put into the middle of vastus lateralis, your quadricep muscle. And I know this because when I was in graduate school, I didn't want to eat ramen noodles anymore, so I volunteered for any study that I could find around the college, and I had muscle biopsies taken. I wasn't part of this study, but they do use anesthesia, but they literally put a small straw into your quadriceps and pull out a hunk of muscle. Excuse me. So from there, they looked at and they quantified the value or the number of muscle fibers between type 1, type 2A, and type 2B. So this goes back to kinesiology, anatomy and physiology, slow twitch and fast twitch muscles. Okay. And what they did is they looked at the cross-sectional area. So how big were the area taken, how big was the area taken up by all of this muscle mass? So here we have the 4 groups. We have a control, a low rep, intermediate, and a high rep. We have pre and post values of the cross-sectional areas of the 3 different muscle types. And then we have an asterisk to denote where there was a significant change, a statistically significant change in cross-sectional area. So I'm going to take a step back, and I want you, someone in the class, to tell me what do you take out of this table? What do the results of this table tell you?
When I first looked at it, the first thing I saw is that the high repetition group didn't have much change at all in either the 3 of them.
So the cross-sectional area of the muscle fibers did not change significantly from pre to post in the high repetition group, right? So if we look across these bottom 2 numbers, we don't see any denotation of significance pre to post for any muscle fiber type for the individuals who did 20 to 28 repetitions. Good. Who else didn't show any changes?
The control group.
Good. Just another indication that the study was good. So our control group and our high rep group did not have an increase in the cross-sectional area of the muscle fibers. What else do we see on this table?
The low rep group had hypertrophy across all muscle fiber types.
Awesome. And you said a key phrase here, that the low repetition group demonstrated hypertrophy across all 3 muscle fibers. Hypertrophy is what we were talking about. Anytime you increase the cross-sectional area of a muscle, that is an indicator of hypertrophy. So Maddie said that the low rep group, we can see denoted by an asterisk here, that they had significant hypertrophy for all 3 muscle fiber types. Good. There's one more thing I want you to note on this on this table? What else do you see?
So did the intermediate rep.
Good. Yep, our intermediate group, the group that did 9 to 11 repetitions, also had significant hypertrophy. So these two groups increased the muscle mass in the quadriceps. Okay, across that 8 weeks, we did see some actual physiologic changes. So if we go between these two graphs that we've just looked at, or these two figures, table 5 and the figure before it, we have performance changes on this table, and then we have physiologic changes in table 5. So certain groups improved their actual performance, and certain groups actually had physiologic changes that were denoted. So can somebody give me a summary of what these two figures together tell us? What's the whole story that this article gives us? Take a shot. Go ahead, don't be scared.
That performance changes can be seen in the 3 tested groups. However, physiological changes are only seen in like the low rep and the intermediate rep groups, and not in the high rep.
So the physiologic changes were linked to performance changes in 2 of our groups. Good. What else? What else? Somebody else give me an idea here.
I feel like what Aaron said, it shows the SED principle, because the 1RM had hypertrophy and a higher 1RM for group A. And then the endurance group showed improvements in endurance and not hypertrophy. And then the intermediate showed improvements in both.
Absolutely, right? So it goes to be very specific about the adaptations we're going to see. So we impose certain demands on these groups, and we had hypertrophy and strength gains in 2 of our groups. We did not have hypertrophy, but we did have muscular endurance gains in our high repetition group. So really what we saw here, right? So here's our continuum, here's our 3 groups. All of our groups, if you go back to that first table, all of them increase their 1RM. So what this tells me is that any type of resistance training is good. It's going to improve your strength. The group that did 3 to 5 improved. The group that did 20 to 28 all improved their 1RM. However, the relative and absolute gains, so their 1RM and the absolute lifting gains, were greater for the group that went into the low repetitions, okay, 3 to 5. So if you really want to focus on strength gains, do lower repetitions, higher weight, and higher rest. The local muscular endurance group, those who did the 60% RM, that increased for the high rep group, right? So if you want to get better at moving a lighter weight a lot of times, things like swinging a baseball bat, throwing a shot put, running, swimming, swinging a tennis racket. If you're going to be doing a movement a lot of times with a little weight, you want to train more on the endurance side of the component. And then we also learned that the intermediate group in yellow and the low rep group in green showed similar muscular adaptations. They both had hypertrophy, and the high rep group didn't have any indications that they had hypertrophy gains. So putting all of this together, if you want to provide your athletes with the best results from resistance training and do it the safest way, where would you be prescribing exercises for your athletes? Where would be the ideal spot to prescribe exercises for the untrained athlete?
Would it be in the middle?
Yeah, absolutely, Kofi. That intermediate group gives you gains in 1 rep max. It gives you some gains in muscular endurance. It does give you hypertrophy. But what can we say about safety for this group as opposed to our high rep or our low repetition group?
I would say that injury is more common with like lower reps when you're trying to lift a heavier weight.
Absolutely, right? Our higher weight athlete or our low rep, especially in an untrained individual, what you're doing is you're elevating the risk of injury for that athlete. They have to move a heavy weight. They have to move it only a few times, but it's that heavy weight in the untrained individual that puts them at risk of injury. So why take that risk? If we can have an untrained athlete move the weight 9 to 11 times and we're still getting hypertrophy and we're still getting strength gains, you're probably safer, as Kofi said, to be in that intermediate range of 9 to 11 repetitions. So this is a great example of the SED principle and how it applies to resistance training. And you can use this to then prescribe weights and reps for your athletes, whether you're working with an individual client or with a team. The tables that are on these following slides are also in your Essentials of Strength Training and Conditioning books. And what they indicate is, where do we want to put the load percentages and the number of repetitions based on a couple of different factors? So if we're talking about the athlete themselves, we can look at beginners should be lifting anywhere from 40 to 50% of 1RM, a lighter weight so that it's safer. The ACSM recommendations are right in the middle, right? This Campos study said 9 to 11. The American College of Sports Medicine indicates that anywhere from 8 to 12 reps is a good general prescription for exercise, for resistance exercise. And then for our advanced athletes, we can look at having them lift 80% or more of their 1RM. So based on the experience, the 1RM percentages that we will use will increase. The other thing we see here is we have to base it on what are the goals for that athlete. Do we want to improve power, strength, hypertrophy, or muscular endurance? What type of athlete doesn't want muscular hypertrophy?
Would you say like a cross-country runner?
Absolutely. And they don't want muscle hypertrophy because that increases their overall mass. And then they have to move this mass across the course. And so the heavier they are, maybe the more difficult. Now, if it's productive hypertrophy, if it's hypertrophy in the legs that actually propel them, that might be okay. But what I don't want is I don't want, a cross-country runner who bench presses and does, biceps all the time and really has this massive upper body, because that's non-productive locomotion weight. So maybe we want to work more muscular endurance with our cross-country athletes. What about our power efforts? what type of athlete would be better fit working in the either multiple or single effort power ranges?
A bowler.
A what?
A bowler.
It definitely could be, right? You get one attempt at throwing the ball down the lanes, and then you get a long recovery in between. Hopefully, it's you throw one and then you get a long recovery before you have to do it again. Anybody who's going to do that short, high burst energy is going to be working in our power, right? So you can use this to help prescribe based on your needs analysis. Get out of here. The other thing we want to do is talk about the overall volume that someone is going to perform. And this has to do with the number of repetitions and the number of sets. The last slide talked about the load based on percentage of 1RM, but the work performed is based on how many repetitions are they going to do and how many sets will they do it. So same thing here. We take our, what is our goal? Do we want our athletes to improve in hypertrophy? And if we do, we're going to prescribe them between 6 and 12 reps, and they're going to do 3 to 6 sets of that exercise. If it's our bowler and we're just looking at power, it's going to be a single effort, 1 to 2 repetitions, but they're going to do 3 to 5 reps. And then rest goes the same thing. We can prescribe rest based on what the goals are for our athletes. Remember, the higher the volume, the longer the rest needs to be. So our strength and power athletes get the most rest, and our endurance athletes will get the least amount of rest. And this just means the time that they take between each individual set. Emily, I think you posted a workout on the discussion board, and that was one of the questions I had is how much time do you take in between sets? And the reason was the heavier load that someone works with, they're going to need more rest and recovery in between each of the individual sets.
I have a question.
Yeah, go ahead.
What if like you're working on like the core and you're only doing like core exercises and you're not using any like resistance?
Okay.
Like
so body weight exercises.
Yeah. Well, what would the rest be like? Would it be like no rest sometimes, or like 30-second rest, or?
Yeah. So if it's going to be low weight or just body weight, then you'll be focusing on a low rest period in between. So that's why you can do several sets of, abdominal crunches in a row, because it's going to be a higher repetition, low rest effort.
Okay. And what's the difference between like a superset and a power set?
Those are, so a superset is basically getting the muscle to a certain level of fatigue where you're stacking different exercises on top of one another. So it may be an agonist versus an antagonist muscle group. It may be different movement patterns, push-pull. Power is going to be the specific type of exercise that you're doing. So you can superset any exercise. Power it's going to be typically a powerful movement, meaning it's going to be higher speed. It will be a lower weight. If you remember from kinesiology, the force velocity curves, that about 1/3 maximal force and 1/3 maximal velocity is where you'll get optimal power. So if I want to train specifically power, what I will do is I will find someone's 1 repetition max, and then I'll tell them move 33% of that weight as fast as possible. And that will help you train a little bit more in your optimal power speed. Good question. Are there any other questions about the repetition max continuum or strength endurance continuum, which you might want to study up on because you might see it again in 2 days?
I actually have a question.
This is good. Hopefully I have an answer.
When you're training for hypertrophy, I had down like, say for example, like you said, like 6 to 12 reps, 3 to 6 sets for hypertrophy. Would that remain the same throughout the whole entire like training plan, or would you increase it? Like, would you increase the number of reps towards the end of the season?
Yeah, that's a good question. It depends on if you retest someone's 1RM. So if you get halfway through the program and you retest their 1RM, you can go back to that 6 to 12 because now you're calculating 6 to 12, or you're calculating the percentage on a higher 1RM than they had when they started out with.
Okay.
Good question. What else? Anything else?
So like part 2 will basically be like the 1RM chart, and we have to like, that's part 2, right?
I can always count on Kofi asking me specifically what question I'm going to ask on the test. Well, I'll tell you this. On part 2, you're going to need a calculator.
A calculator?
Yeah, I know, right? What is this guy thinking? A calculator, math. What did we calculate mathematically that you would need to know?
Load volume.
Oh, shoot.
Bazinga! Yeah, you're definitely going to have to calculate some load volumes. I'm not giving you the 1RM chart, so I'm not going to ask you to utilize the 1RM chart to estimate 1 rep max. Okay, I won't ask that.
Alrighty.
Okay. What other questions are out there that I can answer?
Regarding the workout program, training program, you said today is the last day to send to you for you to like look over it, right?
Please.
Like when you say today, like are you talking about like 11:59 p.m. or like?
Yes, by 11:59 Eastern Standard Time.
Okay.
Okay. And I'm going to wake up. I'm going to set my alarm for 11:59, and then if there's nothing in there, I will know.
Alrighty.
All right. So I'm sure I'll get an email from you tomorrow.
All right.
What other questions can I answer, folks? There are some good workouts posted on our discussion board, so I want to give a special shout out to Matt. I saw Maddie, Emily, and Hannah put stuff up there. We've got some good videos. You guys are much better at this video thing than I am. Those are killer. I can't wait to try them. So if you haven't had an opportunity, go take a look, video your workouts, post a workout for everybody else to do. It's only going to help you in the end.
Is that like extra credit or something?
No, I don't give extra credit. This was extra effort points.
Well, you should give them extra credit for that. That's dope.
I will give them points for extra effort.
All right.
What else do we got? What else do we got? All right, folks. If that's it, I will be online for a little while longer. I am giving an exam at 1 o'clock today to my other class. So I will be around if you want to drop me an email or hop on Google Chat or Google Meetup. I'd be glad to help you out while I proctor the exam. All right?
No problem.
All right. Stay well. Stay healthy. The exam starts at 1 o'clock. The exam starts at 11:30 on Thursday. So make sure you get on there at 11:30, Kofi, 11:30. a.m. Eastern Standard Time. I'm not going to mention any names, Kofi.
No, mention it.
All right. All right,
Thank
folks,
you.
if that's it.
Thank
Peace
you.
out. See you later.